Okay, students, I am very much happy to teach you this small piece of work which I am going to take now. Okay, so here you see that the problem is given to us. Okay, and this is what we see here. The problems is working. And now I will take this problem. Now I am okay in taking this particular problem. Yes, this is what 4 by 4 2 by 2 matrix. I mean, two players are playing A and B, and for A there are 4 strategies: x1, x2, x3, x4. For B there are 4 strategies: y1, y2, y3, y4. Okay, this is what we call the payoff matrix. We know well what is payoff matrix is. Now we have to reduce this matrix into 2 by 2 matrix, then only we can solve the problem, because for 2 by 2 only we can know how to solve that. Now look at this y1, y2, y3, y1, y2, y3. y2 gives you less loss when compared to y1 and y3. I mean, y1 strategies are more losses to B than y2. So if B takes y2 only, then his losses will be very less. That is minimizing his maximum loss. That's what we have to understand. Okay, so delete this particular strategy, and at this particular strategy we will get y2 and y4 strategies only. Okay, so y2, y4 strategies only we are taking into consideration. But for A we are taking as it is x1, x2, x3, x4. So there are 4 strategies are there for A and 2 strategies for B, that is y2 and y4. Now still, if you take the dominance property for the player A, now look at this. This gives less profit than this. Okay, so this gives less profit to the player A than this strategy. Therefore this we can delete. We can get, this is what we have to understand. Okay, right. So here, deleting this x4, we will get this particular matrix. I mean, it's a payoff matrix for the 2 player A and B. So still we have to reduce one strategy so that we can solve this particular problem. So how is it possible? Dominance rule that we have just used cannot be used here, because if one case it is increasing, other case it is decreasing. If one case it is increasing, other case decreasing. So we cannot use the dominance rule there. So what we do, we are using here graphical method. That's what we are using here. Okay, a graphical method, that's what we are using here. So what is the graphical method? The B strategies, I am taking 2 strategies. B, y2 I am taking as B1, and y4 I am taking as B2. So 2 perpendicular line I am drawing now. So between the 2 perpendicular lines I am drawing a line crossing 6 and 5. 6 and 5. 6 in B1 and 5 in B2. So where is 6 here and 5 here? So I am drawing a line. Afterwards 3 and 6. In this line I am taking 3. In this line I am taking 6. I am drawing a line. So in this axis I am taking 8, and in this axis I am taking 4. So here 8 and here 4. Right, now all this above area gives us the maximum loss to the player B, maximum loss to the player B, all this particular area. Okay, maximum loss, wait, place, I have not mentioned that. I have to mention, then only it would be easy to understand. This is what we say maximum loss area for player B, maximum loss for player B. So among these, the minimum point is this. What is his aim? The for player B, the aim is that for player B, the aim is that this particular point, that is minimizing his maximum loss, minimizing his maximum loss. So which is the point here? Maximum loss. The point is this. This is the very lower point, which is a minimum among this maximum loss area. Therefore, this is the point we are considering. Now, note that this particular point, as I said just before, this particular point is intersection of this strategy and this strategy. So, intersection of 6-5 strategy and 3-6 strategy, intersection of 6-5 strategy and 3-6 strategy. So this is two strategies only is involving in this minimax principle. Therefore, these two only we are taking, and this we are striking out. Okay, so this we are striking out. As a result, we are getting this particular 2 by 2 matrix. Then all others we know well. Okay, so what we do here, we are subtracting this element from this element. 6 minus 5, 1, that one we have to write here. Then we are coming to the second strategy. 3 minus 6, minus 3 will come there. Don't take the sign, just write the 3 here. Similarly for player B, 6 minus 3, 3. That 3 you have to write here. And then here, 6, 5 minus 6, minus 1. Don't take sign, write just 1 here. Okay. Now, out of 4 times, 3 times this A has to take to play good game, and out of 4 times, 1 time, that is this 1 time, strategies 2 must be taken by player A. Similarly, B, out of 4 times, 1 time must be taken this particular strategy, and out of 4 times, 3 times must be taken by this particular strategy. So this is the mixed strategy, and they play according to that particular ratio. Now, what's the value of the game of A? Value of the game of A here is like you know the expectation formula. So expectation formula is what? Summation of xi into p of xi divided by summation of pi. So here summation of xi into pi divided by summation of pi. Here this is like probability. Okay, so summation of this is x into 1, 6 into 1, and 5 into 3, 5 into 3. Add both of them. Summation of the probability 1 plus 3, this equals 21 by 4. So if you calculate the value of the game for the second strategy, value of the game for B by taking the first strategy, value of the game by taking second strategy by A by B, all will come 21 by 4. Therefore, the value of the game would be 21 by 4. Right. So with this, I am going to finish this problem. In the next problem, we will be discussing in another example. So thank you very much for your coming over here and listening to this very carefully. Thank you. So